In this tutorial, we'll take a detailed look at a 3-step process that will allow you to set up a maintainable and extendable solution for handling input in your games. And I'm going to demonstrate everything while upgrading this racing project. Choosing the correct input device is one of the most important decisions for your game. A robust input handling allows you to easily add support for different input devices and simplifying the process of porting your game to multiple platforms. So let's get started. You can download the project from the GitHub link located below. To see the current input behavior, let's run the player and focus on the input manager to see what we're dealing with. By pressing W or S keys, we can go forward or backward. It's working, but notice how the accelerator value changes immediately to either 1 or -1. This sudden change in value is a problem because it removes the level of control from the player. We want to get the full range of accelerator values between 0 and 1. Next, pressing the space key will trigger the handbrake. Again, notice how the handbrake value is either 0 or 1. Finally, by pressing the A or D keys, we can steer the car left or right. Again, this is a problem, because we either full steer to the left or full steer to the right. We can slightly turn or adjust our direction by using the keyboard buttons. The current state of the project isn't ideal. Even though the project recognizes keyboard input, we don't have a lot of control over the vehicle. We could achieve a much better level of control if the project offered joystick support. So let's see how to do that. Whenever you're dealing with input handling, the first step should be to download the input system package. Navigate to Window, Package Manager. Make sure your package manager is displaying packages within the Unity registry. Otherwise, you won't see the input system package. Now, scroll down and locate the input system package. Select it, then hit Install. Notice that a loading icon appeared, indicating the download and injection to the project. Wait for the compilation to finish. Unity will show a prompt offering us to automatically expand support for the new input system along with the old input. We don't want both systems supported simultaneously, so go ahead and click No. To disable the native input and enable the input system event handling, navigate to Edit, Project Settings, Player, then look for Active Input Handling option and change it to Input System Package New. Click Apply and let the Unity restart itself. By switching to the new input handling method, we have disabled the old way of input handling, which will cause a bunch of errors. Usually, we want to avoid errors, but this time they're incredibly useful since they point to exact places in code where the old input is still being used. We will fix those errors later. I just wanted to show you how useful it is to disable the old input. Before we dive into code changes, we have to create and assign a map of joystick controls. To create an input asset, right-click in the project window, Create option, and scroll down for Input Actions. Name it Car Controls. Double-click on it to open the Input Action Editor. By default, Unity does not save changes that are made inside this window. To save your changes, either manually click Save Asset after changes or toggle the Autosave checkbox. Create a new action map and we'll name ours Car Action Map. Unity will provide us with a default action, which we'll rename to Acceleration. If we take a closer look at the acceleration action, we will notice that its action type is button. And we know buttons have two states, they're either pressed or released. We mentioned our problem earlier, the keyboard returns only hard values of 1 and 0. The same issue will remain if we leave our acceleration action type as button. Luckily, the joystick has a trigger button that is pressure sensitive and will return a float value between 0 and 1. For this reason, we need to change the action type to value, allowing us to capture the full range of motion from the joystick trigger buttons, rather than just a simple on and off state. If you're still not sure what I'm talking about, this is a perfect moment to introduce you with the Input Debugger. Input Debugger is a tool that helps developers troubleshoot input devices in real time. It allows you to see detailed pieces of information about connected devices, their activity and input events. As I plug in the Xbox controller, Input Debugger refreshes its view and displays it as a usable device. To debug an input device, right-click on it and press Open Device Debug View. A new window pops up displaying the hardware properties that manufacturer exposed for this device, hence showing the whole joystick layout map and the current button states. If I press button East or simply B button on the Xbox controller, we will see that action live. The same will happen if I press the button South. Notice that B, Y, A and X are in fact of type button and will only return values of 0 or 1. For acceleration, we need a trigger button, right trigger to be specific. Scroll down until you see the right trigger option. When I press it, notice how it returns the full range of motion between 0 and 1. This is perfect for acceleration mechanic. We can now get back to the input action editor. Change the acceleration action type from button to value and control type from button to axis. Delete the no binding option and add the positive-negative binding option. Select the positive option and let's assign the right trigger from our joystick. Under the binding, click on the drop-down next to path. Right-click on gamepad, scroll down until we locate right trigger and select it via right mouse click. For the negative binding option, I will assign left trigger button the same way. If you haven't checked the autosave option, don't forget to manually save the asset. Let's add support for this in our code. But first, it's important to generate a C# class from the input action asset. This allows us to treat an input asset like a regular object in our code, making it much easier to interact with. By generating the class, we can directly access the mapped inputs, simplifying the process of managing input instead of relying on references inside the inspector as previously shown. Mark the Generate C# class checkbox. Notice that I've changed the namespace property GameDevBuddy's Simple Car Controller, since it's common sense to keep the same namespace through the feature of assembly definition. You can hit apply now. When the compilation is finished, we'll open the Input Manager class. If we focus on the code update method to be more precise, we can notice that every frame we're checking if any of the input keys are pressed. This approach isn't ideal for a couple of reasons. Poor code readability, maintainability, and we're pulling for key presses every frame even if input values didn't change, which isn't ideal and results with performance overhead and redundant checks. For this reason, we're updating to event-driven input system. This will remove redundant checks, resulting in better performance and code readability. First, let's get rid of old input API code. Remove enums and mapped keyboard button variables. Then, remove the whole update loop. Include the input system library to avoid errors about missing library references. Create a new variable of type car controls. This is the same class that we generated from the car controls input action asset. Add two model behavior methods. I won't go into details, but these two methods get called respectively when component on GameObject is enabled or disabled. Let's add two methods to onEnable and onDisable. One for handling the car control object instance, second one for event subscription. To use the car controls class, we have to create an object instance and enable it. Enabling the action asset is required to ensure the action map is listening for and responding to player input. When we want to stop reading input from the system, call disable method. This will notify the input system and stop event propagation. Now, the most interesting part of this video. To capture the input from system, we have to subscribe to the car controls. Car action map, accelerator. Performed event is triggered when the action is successfully detected or value has changed. When the input action is released or has ended, cancel event is called respectively. Don't forget to unsubscribe from the events, otherwise you'll be stacking event callbacks and end up with tons of data you don't even need. Let's focus on event callback methods and see how we'll read and assign the joystick values. Simply read the callback context as a float value. Back in Unity, when we start the player, we're able to accelerate and reverse by using the joystick. Notice how I'm able to accelerate with higher precision, rather than just giving full gas. We still have to bind the handbrake and steering to our joystick. To do that, modify the car controls input action asset. First, we'll add the handbrake action and set its action type to button, which is default value in this case. In my case, the handbrake will use the A button from the Xbox controller, since I need it to act as a button and not a range of values. Second, we'll add the steer action, set its action type to value and control type to axis. For steering, I'll use the left analog stick, but only the x-axis. Hit save asset and wait for the compilation to finish. Now we should go back to the input manager class and expand our logic. All we have to do is add the missing event callbacks to listen for the handbrake and steer actions. Then, just simply add the missing methods and assign correct event callbacks values to respective variables. Back in Unity, when we start the player, pressing the handbrake on my joystick works as expected. By moving the left analog stick, steer values don't change accordingly. Let's give this baby a test drive. Great, we're still missing one thing, that's keyboard support as fallback. If our players don't have the joystick, we will lose them, so we need to add keyboard support as well. It's worth mentioning that single action can be driven with multiple bindings, allowing us to support multiple input techniques for certain actions. To expand the current system with keyboard support, I'll modify the car controls input action asset real quick. For example, we will now tie multiple buttons to do the same thing. In our case, space and B button will do the handbrake action. Whether it's pressing the trigger on a controller or hitting a key on the keyboard, our game now responds to both with ease. By doing this, we've enhanced our input flexibility, making the game more accessible to players using different devices. With this video, we have only scratched the surface of input system possibilities. If you'd like to see more detail and specific input system tutorials, let us know in the comment section below. If you don't want to miss a follow-up tutorial on this subject, make sure to subscribe. If you're interested in a different topic regarding Unity, check out our channel on how to achieve a AAA snow transition shader. Thanks for watching and see you in the next one.